Hello everyone, my name is Shambhavi. Hope you all are doing well. So today we're going to start out a new topic in the statistics for data science, and that I would just write that out and spell that as well. That what's the next topic that we're going to start up today. Just quickly let me take out a pen so that it is suitable for me to go ahead and write out. Yeah. So the next topic that we're going to start out here is chi-square test. Okay, this is the next topic that we are gonna go ahead with in the statistics. Right. Now, when it is start out a topic, the very first question that comes into my mind is that why is the statistics necessary or compulsory to study out this particular topic, right? As well, we are having many of the topics already. We have studied a lot in the statistics. Then how come these new topics and why are these particularly used? Why did these kind of topics came into existing? And all these questions I really have in my mind before starting out a new topic and before learning out a new topic, right? So first of all, I'm going to answer out all these questions. Then afterwards, I'll be taking you completely to the chi-square test, okay? So let me just quickly take out a different pen color here so that I could proceed on with the writing as well. And here we go. Okay. Now, here I have some you could say some thinkings for you all. Okay. So let me just put on the number one. So I will just write these things as well. Okay. So it's have you ever wondered? Have you ever wondered if if a lottery if a lottery if a lottery numbers were evenly distributed. Distributed. Did you ever thought that what if the lottery numbers which are there, all of those were simply evenly distributed? Then what could actually happen out? Or what could actually occur? Right. This is one of the wonderings which you should actually pay attention towards. Right. Next, let's say and the evenly distributed numbers we were having, and if some of the numbers were occurred with a greater frequency, then in that case what would have been happened, right? Next one of the wonderings, you could even go ahead with that. uh, how about that if the types of movies people preferred were different across different age groups? Right, yes, it actually happens out that according to different age groups, the type of movies actually differs out, right? So what could happen in that? Next, basically, what if a coffee machine was dispensing approximately the same amount of coffee each time, right? So basically, all of these questions can be answered. What are the questions I just mentioned about, right? Three to four questions. These can be mentioned with the help of the hypothesis testing, right? We could just simply apply out the hypothesis testing into that, and we could simply answer out these questions. Hypothesis testing we are already very much aware of, right? So I just do not need to again read that right here, right? So that was you could just answer out this questions by simply conducting out a hypothesis test. Now, basically you have to study about a new distribution here which is completely used to determine the answers of the above questions which I had actually given you. Right here I have just mentioned 2-3 questions, right? That what if a coffee machine pours out like similar amount of coffee every time, and what if the type of movie differs in the type of age group, right? So in that case, now we have to study about a new distribution that would be completely used to follow out the answers, to find out the answers of these above mentioned questions, and that particular distribution is chi-square distribution, right? So I would just write that name here, distribution. Okay, here we missed out a square, so I would just add on a square, and here goes the distribution, right? This is basically what the chi-square distribution is completely used for, right? Hope I am very much clear with this particular thing. Okay, so now basically we'll be learning about many different things right here in this particular module, so I will just not waste of too much of time in the in this particular thing, let me take you to the notation part of this square distribution. Okay, that basically how we denote out these all of the things, right? What's the denotation? What symbols do I use? So here goes the notation. Okay, and right here I would just take out. Okay, let me go ahead with this only. Let me click on cancel. Great. Okay, so basically the notation for chi-square distribution. So basically the notation for this particular thing is we simply write out here x and we simply not like this. It's something like this, right? X is square and that's approximately equal to, I would just put simply like this only. That's completely equal to x and here goes the square and here goes the df, right? So I would mention it like this right here. Great. So this is the notation, this is the denotation for this square distribution. This is how we denote it out actually, okay? Now what does this df actually means out here? So I would just mention that as well. So df is equal to, that is the degree of freedom, depend on how this square test is being used. Okay, this is what this df means, that it is a degrees of freedom depend on how this square test is being used out, right? So yes, this is the idea regarding this df as well, that what does it actually means out. Okay, fine. Now basically if we just want out a practical calculation using the this chi-square probabilities, then in that case we could simply use out here df is equal to n minus 1. Okay, that would actually happen. That will give you the like the probability, the calculation for the particular calculation. Okay, right, that's absolutely okay. Now next let's come down here because I have some more things to tell you regarding this denotation only. Okay, here we go. That for the x square distribution, which we had seen right above. So for the x square distribution, the population mean is mu is equal to df. So basically if you are having a distribution that's x square, so for that the population mean is mu is equal to df. Okay, and the population standard deviation is sigma is equal to under root of 2 multiplied by df. Okay, I just did not put out the multiplication sign. 2 multiplied by df, right? The 2 you are already aware that what it's 2 is a simpler number. Dot is basically multiplication. What's that df? That's df is the degree of freedom which we had seen right above, right? So whenever you are having the x square distribution, so in that case for finding out the population mean, the formula is mu is equal to df, and for the population standard deviation it is sigma is equal to under root of 2 point df, right? Next, the random variable is shown as it's not that x, like it's some completely like this. Okay, that random variable is shown like this, shown as this much, and but it could be a but maybe any, let me just calm down first of all, but maybe any uppercase. That's not related to right here, because maybe some of you must be having out the doubt that the denotation for this random variable and it is absolutely same. So how would I differ that? What is it and what is that actually? Okay. So in that case, this is a sentence which I have written. You could follow this out. Okay. Now, we have the random variable as well. So the random variable for the random variable for the chi-square distribution, the random variable for the chi-square distribution which has the degrees, that is k. Okay, I would write out with k degrees of freedom, is the sum. Let me just calm down. Is the sum. Okay, 1 second. Right here. So is the sum of k independent squared is the sum of k independent squared standard normal variables. Right? So what's the denotation for that? So the denotation for that is x square is equal to, here we have z1 square plus, then we have here z2 square plus, and here we have zk square. Okay. So yeah, this is the denotation regarding the degrees of freedom as well for this particular sum. Now, right, we're letting you know about the two facts about the chi-square distribution. We have two facts here regarding this particular thing, okay? So I'll just give a little bit time regarding that as well. So let me quickly take out a pen right here once again, a different color. Okay. So here it goes that facts about the chi-square distribution. Okay, this is the facts about the chi-square distribution. Let's come down here, go ahead with the very first one. And the very first fact is that the curve which we have here is non-symmetrical, and is skewed, sk is skewed to the right. So the curve which we are having here in the chi-square distribution, that's the non-symmetrical, and it is skewed towards the right. Okay. Next, that there is a different square curve. There is a different square curve for each DF, for whatever the each DF, like for whatever the degree of freedoms differently you are having. So for every of them, we have a different set of curve. We have a different curve which we get out by the relevant values and the points we get out, right? So yeah, hope I am very much clear with you all with all of these things regarding the chi-square test, that what it is, what's the notation for that, and basically what's the fact regarding this particular thing, right? We'll be seeing about more things in the next videos. So this is all for this video. Till then, thank you and take care.